Hey everybody, I wanted to take some time to go over the problems in the Classwork document I posted. So I've already done a few of these in class, but some of you may not have seen them, so I'm going to go over the few that I have done, and then hopefully work through most of these. So if you have any questions, we can hopefully answer them. Alright, so let's get started. So again, this is about similar triangles, and the three reasons triangles can be similar are side, 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 angle, angle, and side, angle, side. And when you see S's, when I say side, it doesn't mean the sides are congruent, but it means they're proportional, okay, which we'll get into in a moment. So anyway, first part, it's asking us to state if the triangles in each pair are similar, and if so, state how you know they're similar, and then also complete the similarity statement. So these first two are not congruent, spoiler alert, and I'll show you why. So this first triangle up top has one arc, three arcs, and four arcs. Let me zoom in so you can see a little clearer here. Okay, so we have one arc, three arcs, and four arcs. Now this one has one arc, this has two arcs, and there's no arcs here. So there's only one angle that matches up with this triangle up here. We don't know if this is a 3 or 4, we're not sure. We just don't have enough information, so therefore it's not similar. If this arc or that arc was matching up with one of those, just one of these, then we'd be fine, because that'd be angle, angle, because we already have the single arc matchup. Alright, so look at number 2. So 2 is not congruent for another reason. We're not given any angle information, so the only possibility would be side, side, side. And they give us all three pairs of sides. So we go ahead and set up our proportions, or sorry, set up our ratios rather. And we find that they're not all the same. So we take, for example, take the largest side. So I believe I did blue over red. So we have the smallest side for the top triangle, the blue triangle is 5. The smallest one down here is 10. So you go small over small, so 5 over 10 is 1/2, okay. And then the middle side here, the next largest side for the blue is 6. The next largest side here is 14. 6 over 14 is not 1/2. And same thing, the largest side, 11 over 20 is not 1/2. So they're not all the same. The ratios should all come out to be the exact same value, but they do not. Therefore, it is not congruent. Let's check this one down here. Now this one is congruent, number 3. If you're doing this at home, I would definitely recommend using the colored pencils, or I don't really recommend pens. I'm using them because they show up better in the video, but I think they really make this topic a lot easier to process because you can actually see the different triangles. It's especially hard when they're drawn on top of each other like this, so the colors I think help. Okay, so we're going to do the exact same thing we did for number 2. We're going to look at the sides and they correspond, right? So the smallest side for the blue triangle is 8. Right, the smallest side for the larger triangle is 24, so 8 over 24. And then this side here, which is 12, so 12's here, and then the larger side here is 12 plus 24, which is 36. You have to add those together for the whole red side. And then over here, 13 over 13 plus 26, because the whole red side is 39. Now all of these come out to be 1/3, so they're all equal to each other. The ratios are the same. Therefore, we know it's side, side, side. We have to finish our similarity statement. So it goes STU. So we're going to look at SGH, and it's in that order. Okay. All right, let's try one. So I've not done these, so let's see what we find. I've not done these next ones. So okay, so we have an angle here. All right, so angle here. And we have sides, and then the angles included, so this could be side, angle, side. Let's see. So let's go ahead and go blue over red. So we're going to go 15 over 70. And then we're going to go 24 over 113. Okay. Well, let's see. So 15, well, let's get rid of that. 15 divided by 70 is whatever that is. 24 divided by 113. So they are identical values. These are proportionate. So side, angle, side. And now we're going to go, see, A, B, C. So A, B, C, so A, S, T. Alright, let's check something else. Let's see if the small over the big within the same triangle is the same as the small over the big in the other triangle. Let's just test that out. Let's see if that works. 15 over 24, 70 over 113. Let's see if those equal the same value. Let's find out. So 15 divided by 24. Alright, and then 70 divided by 113 does not. Interesting. Okay. So there we go. It's triangle ABC is similar to triangle AST, and because of SAS. Alright. Well, let's move on here. So we got number 5. Okay. This is looking very similar to number 4 that we just did. So we have an angle and an angle. Okay. Let's see if these sides, these corresponding sides, are going to be same proportion here. Let's see if it works. So blue over red. So 20 over 182. Then 28 over 130. That doesn't seem right to me. I think I might have screwed up. Let's see. We'll find out in a second. I don't think I did. Say 20 divided by 182. And then 28 divided by 130. Okay, I just want to check one thing. Let me pause this because I'm curious if I made a mistake on something here. So my instincts were correct. I did make a mistake. So I think I just looked at the calculator really fast. And the reason I felt like I made a mistake is that this should have worked. This should have worked. And I went back and rechecked the math here. So 15 over 70 and 24 over 113. And look, I looked at it too quickly. Look, these are not the same. That's a good example. If you go too fast, you can make a mistake. Look, I just made a mistake. So it's pretty easy to make it. So these are actually not going to be similar. So I'm glad I caught that. If you're ever not sure, just go back and check your work. With math, it's so easy to make a mistake. Look, I've been doing these for a while, and it's not that hard to make a mistake. So let's see here. Excuse me. So we're going to set this up the same way. And I made another mistake because look what I did here. I think I'm still waking up, guys. This happens when I try to record a video too early in the morning. So these ratios are not correct. I should be taking the smaller value over the smaller value, but that's not what I did here. Look, I put 20 over 182. I should have 20 over 130 because that's a smaller value. So these are not correct. All right, let's do this correctly as I confuse everybody. So 20 over 130 and then 28 over 182. Now we can see if it works. All right. So I may not. Another thing too is when you're trying to rush like I was, trying to get this done before first period. It's easy to make a mistake. If I don't finish before first period, no big deal. I'll just do a multi-part video. So 20 divided by 130. Let's see what we get. So we get that. And 28 divided by 182. I get that. So let's check. Yes, those are identical. So these are proportionate. Therefore, this is SAS. Okay. And PQR, so PQR, that's a smaller one, so we got a small one, PCD. Triangle PCD. Okay? Now let's check number 6. So we have 3 sides, right? We're going to go big over big, small over small, middle over middle. Okay, we're going to do blue over the red. So the smallest side is 8. And the smallest side up here is going to be 16. So 8 over 16. And then the middle side here is 13. The middle side here is 26. So 13 over 26. Excuse me. And then 14 is the largest. 28 is the largest. 14 over 28. Now these all look like 1/2. Yes, they are all 1/2. So these are all proportionate. So this is a pair of similar triangles because it's side, side, side. It's probably more obvious. There you go. And let's go in order. So U, V, W. So small, big, right? Yeah, small, big. So let's see, small, big. So F, G, H. Triangle F, G, H. That's it. Okay. Number 7. So again, we're given, okay, we have an angle right here. They both have that angle in common. So we're going to see if these sides are proportionate. If they are, then we know it's side angle side. So blue will be our small, which is 18. 18 over the red, which is going to be this side, which is 18 plus 30, which is, what, 48? Why did I put 148? That makes no sense. Okay. And then 21 over this whole thing, which is, what, 56? And then let's see if that works. So I don't think that does. Let's make sure I did that right. It's 21, 56, yep. 18, 40, yeah, okay. Let's see if those are the same, though. I don't know if they are. 18 divided by 48 is that. Well, maybe they are the same. Let's see. They are the same. Look at that. So these are proportionate because of similar, rather, because of side angle side. So D, CB, so DKL. Okay. Here, similar problem. We have, this is actually very similar to number 6 because it's 3 pairs of sides. So let's go ahead and identify the smallest side, which is 10. 10 over, and then the small side up here is going to be, what, 15? Yeah. 15. Okay, the middle side down here is 14. And then the middle side up top is going to be 20. Okay, and then the largest side down below is 17. The largest side up top is 27, so it's going to be 17 over 27. Okay, let's see if those are all the same. I don't think they are. Now, this is 2/3. This is not 2/3. This is not 2/3. Let's just verify, but I can already tell this is not going to be, these aren't going to be the same. Let's go there. That. So 10 divided by 15 should be 2/3 or 0.6 repeating. Yep. 14 divided by 20 is going to be close to it, but not the same. Yeah, very close, but no. And then 17 divided by 27. Not sure what that is. Okay, so none of these are actually the same, so therefore this does not work. It's similar. Okay. Let's look at the next one. Number 9. So again, these share this angle here. See that you can see it's going to be side angle side if it works. So let's go ahead and check these sides. So it'll be blue over red. Now they don't give us the blue, but we know the red is 14. This is 7, so the difference would be 7. So that has to be 7. So 7 over 14 because it's blue over red, and then blue. Red, so it'd be what, 6 over 6 plus 6 is 12, so 6 over 12. But why do I use a different color? 6 over 12, and those are both 1/2. So that works. Awesome. So side angle side, and UVW. So UVW. So from here to here, so it's gonna be UBC. Triangle UBC. Okay. Some water real quick. Okay, so we know these angles are congruent because they're vertical. So they don't give us any sides. So if these are going to be similar, it's going to be because of angle. So what that means is that they have one angle in common. One of these needs to match up with one of those. Now, this is 55. This is 56, this is 46. So I don't see a 55-degree angle over here. So it doesn't work. Not similar. And here's the deal. You're saying to yourself, well, yeah, but what if this is 46 or 56? It can't be. It actually cannot be, because think about it. If these are the same, that means these are the only two angles left, which means one of them would have to be 55 if these triangles were similar, because similar triangles have three pairs of angles that are congruent. All right, that finishes the first page. Let's look at the next page. Number 11. All right, here we go. Excuse me. All right. Find the missing length. The triangles in each pair are similar. So they tell us the triangles are similar. Now we're looking for the missing value here. Okay, so we're looking for that. All right, so we're going to assign a variable. It's going to be x. And our small triangle will be blue. Okay, so x over this whole thing, because the corresponding red side would be here. So x over 42. Now there's a few ways to solve this actually, because they give us all the other sides. We're going to go this side, this AF over AB. So 12 over this whole thing is 36. Now from here you just cross multiply and solve, just like in section 7.1. I'm going to simplify this just to make the numbers a little more manageable. You don't have to do that, but I like to do that. Some of us don't like to do that. That's all right. I'm going to divide these both by 12. We're going to get 1/3. For me, I just find that much easier. But if you don't like doing it, you don't need to. You can go right to the cross multiplication. So 3 times x is 3x. 42 times 1 is 42. We're going to divide by our coefficient, which is 3. And x will be equal to, let's see, 3 divides 4 once. 12, 14. There you go. Find each missing side. That is a missing side. Sweet. Okay, let's check this one. So this is our missing side. That's going to be our x. So blue over red. So x over 70. And then we have to do these because they don't give us those ones. All right, so blue over red. So 33 over 55, it looks like. Yep. So 33 over 55. Now, you might be saying to yourself, well, it's cross multiply. But I know these are both divisible by 11. Which will make this 3/5, which I would much rather work with than 33/55. For 50/5, it's hard to say that. So we're going to divide these both by 11, so we're going to get 3/5. Okay. And now we're going to cross multiply. And 5 times x is 5x. 70 times 3 is 210. And we're going to divide by 5. Okay. X is equal to, let's see, 42, I believe. Yep, 42. Awesome. Okay. Number 13. Okay, we're going to have to use a similarity statement on this part. So we're looking for that side there. That's going to be our red. So RT, we have to pay attention because we don't really know which of these two sides the red one matches up with. We can't tell because it may be the orientation may be switched, it may be flipped, twisted. You can't really tell. So we have to go to the similarity statement. So RT is the first and last letter. So the first and last letter of this triangle is DF. So DF is here. So DC, yeah, notice because a lot of people would say, oh, well, the red's on top of this one. It doesn't have to necessarily be on top. So we have to pay attention to that similarity statement. And I'm gonna put the red on top of this one because I want the variable on top. I don't know why I'm just doing that. So x over 50. And let's just verify this. I'm pretty sure we'll be fine. RS is the first two. DE, yeah, those are the first two. Just for consistency's sake. So this is our red, and this is our blue. So it's gonna be 81 over 45. 81 over 45. Those are both divisible by 9, so x over 50 is equal to 9/5. Yep, and then cross multiply. And again, you don't need to do that. You can go right to cross multiplication, but I just like to do that. 5x equals 9 times 50 is going to be 450, I believe. Yeah, 450. Now we're going to divide by the coefficient, which is 5. And that should give us 90, I believe. Okay, awesome. Number 14. let's see. Again, we're going to use a similarity statement. So this is our x value. That's going to be our blue. SL is the first and last. So the first and last here is SU. So SU is here. So it's going to be x over 91. Okay. And then 55 over 77. And again, these are divisible by 11, so let's go ahead and make our life easier here. So it's going to be 5/7. I'm going to cross multiply. 7 times x is going to be 7x. And then 91 times 5, so that's 455, I believe. 5 times 1 is 5, 5 times 9 is 45, yeah, 455. Is that divisible by 7? I guess it is. I don't think I've ever gone that high with 7s. Is it? Yeah, I think it is. Let's find out. Yep, 65. Sure enough. It's a trivia question right there. X equals 65. Alright. Let's look at 15. So, okay, we're looking for the question mark, which is here. That's going to be our x. So TV is the first and last. The first and last over is FH. So FH is here. So x over 13. And then TU over 10. So 30 over 10. What am I doing? Sorry. 30 over 10. And those are both divisible by 10, so we're going to get x over 13 equals 3 over 1. So cross multiply. We're really just multiplying by 13 here, but you get the idea. X equals 39. There we go. Alright. 16. That's our x value. So JK is going to be first two. First two are JU, so JU is here, so x over 33 equals, and then JL, which is the first and last, over the first and last, which should be JV, which it is, so 126 over 27. Okay. I don't know if those are divisible by something. Is that divisible by... we're not going to worry about it. I think you can... Yeah, they're both divisible by 3. I know that because these add up to something divisible by 3. Is that divisible by 9? It is divisible by 9, but we're not gonna do that. We're gonna just do it this way because I bet most of us are actually just going right to the cross multiplication anyway. So 27x, and then 33 times 126, 4,158. Then we can divide by our coefficient, which is 27. 27, and that is going to equal 154. Okay, so x equals 154. Ooh, went too fast there. X equals 154. There we go. Okay, almost done, guys. There we go. Coming down the home stretch. Solve for x. Triangles in each pair are similar. All right. Right. This is similar to what we just did. We're just solving for a variable. Okay. So the side we're looking for is up here. So FG are the first two letters. That means UT. So it's going to match up with that. So we're going to have 8x minus 10 over 13. And then GE, which is the first and last. US, yeah, first and last. So 66 over 11. They're both divisible by 11. This actually just equals 6. So 8x minus 10 over 13 equals 6. I'm going to multiply both sides by 13. So 8x minus 10. I might run out of room if I'm not careful here. 6 times 13, so 72, 78, I believe. And then we're going to add 10. Add 10. 8x equals 88. Divide by 8. And x will be equal to 11. Okay. So we're going to solve for this value, which is JT. So JT is the first two letters. Therefore, the first two letters over here are JK. So we have 5x minus 4 over 126. And then JS over LJ. Okay, we're going to cross multiply here. Oh, what did I do here? Oh, look at this. This is an isosceles triangle. Interesting. I was getting confused there. So this is actually equal to 56. Because if we multiply both sides by 126, those go away. Okay, that makes our life a lot easier. So 5x minus 4 equals 56. I got confused. I thought I miswrote it. We're going to add 4 to both sides. Okay. 5x equals 60. We're then going to divide by 5. And x will be equal to 12. Oh, I did not take the trash out. I just realized that. I'll be right back, guys. I'm going to go take it out real quick. Okay, there we go. Crisis averted. Alright, so these are all set. Number 19. We're solving for x, which is right here. TU is the first and last. First and last here is PQ. So we're going to write 2x minus 19 over 21 equals. And then the blue is TS, which is the last two. Last two QR, yeah, there we go. So 10 over 30, which is going to be 1/3. So 2x minus 19 over 21 equals 1/3. So cross multiply. And we're going to have 3 times 2x minus 19 equals 21. And you could divide by 3 there, but we're just going to distribute it. 6x minus 57 is 21. And then we're going to add 57 to both sides. 6x equals 78, which I think is 13. Let's see, divide by 6. What am I doing? Divide by 6. See how I said 13, I wrote it down? I do that all the time. Yeah, 13. Cool. X equals 13. Nice. Alright. Almost done here, guys. We're working our way through this. So, and I know these are a lot of examples, but it takes a lot of practice, I think, to get used to these. Alright, so here's our unknown here. We're looking for x there. So QT is the first and last, and QT is Q and S, so that's going to be this one here. So we're going to have 2x minus 2 over 70 equals QU, which is first two, QR, the first two here, so 12 over 42. Okay, those are both divisible by 6. We're going to get 2 over 7. So 2x minus 2 over 70, and that's going to be 2 over 7. Okay. So you want to get some real crazy stuff. We know this is going to actually be equal to 20, because if we multiply this by 10 over 70, yeah, it's going to be equal to 20, but there. That's neither here nor there. Don't want to get even more confused than we already are, probably. 7 times this equals 140, because 70 times 2. Now I distribute the 7. I just made it in time. There is a trash truck. I'm proud of myself. And minus 14 equals 140. We're going to add 14. I think x is going to equal to 9 here. I just used some wizardry. 14x equals 154. And I think this is going to equal 9. Let's see. Maybe not. Let's find out. 14. No, it's no, it's not going to equal 9. I got full of myself there. Let's get rid of that. 154 divided by 14. 11. Well, it was worth a shot. X equals 11. Alright, last two. Here we go. Hey, Stink. So, oh, there's a cat. Stinky, get out of the way. Come on. Get out of there. Alright, so, let's see. Our X value is LM. LM is here. So LM is the first and last. That means the first and last of the other triangle are CD, right there. So CD is here. So 44x minus 2 over 39 equals, let's see, 130, which is NL, which is the first and last. And CE is the first and last here. So C. Oh, what are you doing, Stank? You're screwing things up here. That's what happens when you try to do stuff with a cat. Alright, she gets in the way here. Alright, so we got 130 over 39. This looks like it is another isosceles triangle. So we can actually eliminate the 39s in the bottom, because if we multiply both sides by 39, these go away. So we have 44x minus 2 equals 130. And we're going to add 2 to both sides. So 44x equals 132. Divide by 44. And I think that's equal to 3. Let's just double check that. So 132 divided by 44. Okay, so 44. Yep, it's equal to 3. Awesome. Okay, the last one. There we go. The last one. And then we are going to finish in time. Nice. All right, so this is the blue. This is going to be our red. Now they don't give us a similarity statement here, but we don't really need it. Turns out we don't need it for this one. So 26 plus x over 10, and 40 over 10. Oh, I like it when they do the isosceles ones. So we're going to have 40 over 10. These effectively cancel, so 26 plus x equals 40. Oh, nice easy one at the end. That's nice. Minus 26. Minus 26, and I believe x is 14. Yep, and it is. Alright guys, so I hope that helped. I know that was a long video, but I wanted to take the time to go over all these because I think it's worth it. So please let me know if you have any more questions, or if you think I made a mistake, let me know as well. Alright, see you guys soon.